Hello everybody, welcome. In my previous video, I discussed the properties of complex numbers and I also discussed the addition, subtraction, multiplication and division procedures of complex numbers. Today I am going to solve some related exercise problems. I have compiled these exercise problems from different textbooks. So let's solve. Here you see we need to simplify the followings. The number one is I cube. Now the target is to split it in terms of I square. I solve one for you and you will understand. So I cube can be split as I square multiplied by I. Now we know that I square equals to minus 1 and one I is still left. So it makes minus I. Now the second problem, this is I to the power 4. So I can split it in terms of I square multiplied by I square. Now we know that I square equals minus 1. So we have got two I squares here. So I write 1 minus 1 and another minus 1. And when we multiply minus 1 by minus 1, we get plus 1. Now number 3 is I to the power 6. So I can write I square multiplied by I square multiplied by I square. So we have got three I squares here. So we can put minus 1 multiplied by minus 1 multiplied by minus 1. So it makes minus 1 multiplied by minus 1 is plus 1 and plus 1 multiplied by minus 1 makes it minus 1. Now we have got I to the power 9. So I can split it as I square multiplied by I square multiplied by I square multiplied by I square and then I. So I have got 1, 2, 3, 4. 4 I square. Okay. So the result is minus 1 multiplied by minus 1 multiplied by minus 1 multiplied by minus 1 and then I. So we find plus 1, minus 1 and plus 1. So it becomes plus I. Thank you. Now when the power of I is very big, we try to condense things together. How we do that? Say for example, we need to calculate I to the power 10. So we can write it as I square to the power 5, because from index law we know that we can split the index like this. So 5 times 2 is 10. So I squared to the power 5. Now I square equals minus 1. So it becomes minus 1 to the power 5. Now if the power of minus 1 is an odd number, you can write it minus 1. Okay, so if the power of minus 1 is an odd number, you can write it as minus 1. If the power of minus 1 is an even number, you can write it plus 1. Okay, say minus 1 to the power 7 equals minus 1. But minus 1 to the power 8 equals plus 1. Okay, because you see 7 is an odd number. So minus 1 to the power 7 equals minus 1. 8 is an even number, so minus 1 to the power 8 equals plus 1. So what happens if I try to calculate I to the power 15? I can split it I squared to the power 7 multiplied by I, because 7 times 2 is 14 and then 1 I left, so I just write I. Okay, now I can write I squared as minus 1. So it becomes minus 1 to the power 7 multiplied by I. So as minus 1 to the power 7 is minus 1 multiplied by I. So it becomes minus I. Here we need to express the following complex numbers as A plus IB. So the first one is 3 plus 2 square root of negative 1. So we can write it as 3 plus 2i, because square root of negative 1 is I. So here my A is 3 and B equals 2. The next one, 6 minus 3 square root of negative 1. So I can write it as 6, then I put a plus sign and I write minus 3 in brackets, and then square root of negative 1 can be written as I. So here my A is 6 and B equals minus 3. So I hope you understand. Thank you. Sometimes we may need to solve quadratic equations like this, but be careful, we need to rearrange it. We need to write the square terms first. Okay, so here it is 4z minus 3 minus 2z square. So we need to write minus 2z square first, then we write plus 4z, and then we write the constant term, that is minus 3. Now this is an equation of form ax square plus bx plus c. We know that a quadratic equation, that is ax square plus bx plus c equals 0. Now the solution of this equation is x equals minus b plus minus root over b square minus 4ac divided by 2a. Now if we apply this formula, we can write it z equals minus b. So what is my b here? My b here is 4. Okay, then plus minus root over b square minus 4ac. So my b is 4, so I write 4 squared, that is 16, then minus, then 4, then a. What is my a here? My a is minus 2. Okay, be careful about the negative sign. It is not plus 2, it is minus 2. So my a is minus 2, and my constant term is again minus 3, not plus 3. It is minus 3. Okay, minus 3. So divided by 2a. So my a is minus 2. Now we calculate and it becomes minus 4 plus minus 16, and then 4 times 2 is 8, 8 times 3 is 24, and minus makes it plus, and then plus and minus makes it minus. So it becomes minus 24 and divided by 2 times minus 2, that is minus 4. Now we can write it as minus 4 plus minus square root of 16 minus 24, that is minus 8, divided by minus 4. Now we can write it as minus 4 plus minus. Now look at this. This is square root of minus 8. So I can write it as square root of 8 multiplied by minus 1 divided by minus 4. And I can write it as minus 4 plus minus 8 root 8 times square root of minus 1 divided by minus 4. And then I can write it as minus 4 plus minus root 8 I, because square root of minus 1 is I. Okay, so I extend it here. I am writing here. So the result is minus 4 plus minus root 8i divided by minus 4. Now you can split it. Minus 4 divided by minus 4, minus 4 divided by minus 4, and then plus minus square root of 8 divided by 4, and then I. Okay, thank you. We need to solve this equation. This is x plus iy equals 4 minus 2i. Now, from the properties of complex numbers, we know that if two complex numbers are equal, then their real parts are equal and their imaginary parts are also equal. Here you find two complex numbers. This is x plus iy, this is a complex number, and 4 minus 2i, this is also a complex number. So the real parts of both equations will be same. So the real part of this equation is x, the real part of this complex number is x, and the real part of this complex number is 4. So I can write the real parts are equal, so x equals 4. Now the imaginary parts of this equation are same. So the imaginary part of first complex number is iy, and the imaginary part of this complex number is minus 2i. So I can write y equals minus 2. Now we need to solve this equation. So here again we see we have got three complex numbers, x plus iy, and then 2 plus I multiplied by 3 minus 2i. So what do we need to do? We can write it as x plus iy. Now we finished the multiplication here because 2 plus I is multiplied by 3 minus 2i. So we do the multiplication, that is 2 times 3 is 6, then I times 3 is plus 3i, then 2 times minus 2, that is minus 4i, and then I times minus 2i, that is minus 2i square. Now we can write it as x plus iy equals 6 plus 3i minus 4i, now minus 2i square. So we know that if we find I square, we can write it as minus 1 because I square equals minus 1. So I can write it as minus 2 times minus 1. Now I can write x plus iy equals 6, and then this becomes minus 4i plus 3i minus I, and then minus 2 times minus 1 is plus 2. Okay, so I can write x plus iy equals 6 plus 2, that is 8 minus I. Now we find just two complex numbers here. One is x plus iy and the other one is 8 minus I. So we know that the real parts are equal. So here the real part is x and here the real part is 8. So x equals 8 and the imaginary part is iy and the imaginary part is minus I. So I can write iy equals minus I, and hence I can write y equals minus 1. We need to solve this equation. So what we can do, we can cross multiply and it becomes x plus iy multiplied by 2 minus I equals 7 plus I. Now if we complete the multiplication, it becomes 2x plus 2iy, then minus ix, and then minus I square y equals 7 plus I. Now we can write 2x plus 2iy minus ix, and instead of I square I can write minus 1, so minus 1 times y equals 7 plus I. So it becomes 2x plus 2iy minus ix plus y equals 7 plus I. Now we need to collect all the real numbers together and all the numbers with I together. So I write 2x, then plus y, and then 7 on my right hand side. If it comes on my left hand side, it becomes minus 7. So 2x plus y minus 7. These are all real numbers. Now, what are the imaginary numbers? The imaginary numbers are 2iy. So I take I common, okay, and write all other numbers in the inside the bracket. So it is 2iy. So I have got I common, so I can write it as 2y. Then minus ix, so I can write it as minus x. And then this plus I on my right hand side, if it comes on my left hand side, it becomes minus I. And if I take the I common out of it, it becomes minus 1. So hope you understand. We have collected all the real numbers. So 2x plus y minus 7. 7 comes here, it becomes minus 7. Now we need to collect all the numbers with I. So I've got 2iy, then minus ix, and then plus I on my right hand side. So everything comes together and I take I common of it. So it becomes I multiplied by 2y minus x minus 1. And then I write 0, okay? Now, we know that the real parts of a complex number are equal to real numbers, and the imaginary part is equal to imaginary number. Now in this equation, on my left hand side, the real numbers are 2x plus y minus 7. On my right hand side, there is no real number except 0. So I can write 2x plus y minus 7 equals 0. And on my left hand side, numbers with I are 2y minus x minus 1. 2y minus x minus 1. On my right hand side, there is no number with I except 0. Okay, so I can write it as 0 as well. Yeah, you got it? The real numbers on my left hand side is 2x plus y minus 7. And there is a 0 on my right hand side. Nothing else. So I can write this real part is 0. And on my left hand side, the numbers with I are 2y minus x minus 1. On my right hand side, there is 0 only. So I can write 2y minus x minus 1 equals 0. Okay, so we have got two equations. Now we need to solve these two equations by any method, like by method of substitution, method of elimination, whatever you like, or you can use your calculator to solve these two equations, okay? And then you find the number of the solution of x and y. So this is the procedure you solve this equation. Thank you. Now we need to solve this equation, that is x plus iy equals 2 minus 3i whole square. So what we do, we write x plus iy, then we expand this one, 2 minus 3i whole square. So it is the formula of a minus b whole square. So that is a square minus 2ab plus b square. So it will be 2 whole square minus 2 times 2 times 3i, then plus 3i whole square. Now we can write x plus iy equals 2 square equals 4 minus 2 times 2, 4, and 4 times 3 is 12. So it is 12i, and then plus 3i whole square. Now 3i whole square means it becomes 9i square. Now I can write it as x plus iy equals 4 minus 12i plus 9i square. So we know that I square equals minus 1. Okay, so we can write it as 9 multiplied by minus 1. So it becomes x plus iy equals 4 minus 12i minus 9. Now I can write x plus iy equals 4 minus 9, that is minus 5, and then minus 12i. So we know that real parts are equal to real numbers and imaginary parts are equal to imaginary numbers. So here my real number is x and here my real number is minus 5. So we get x equals minus 5 and iy equals minus 12i. The imaginary part is iy, and the imaginary part is minus 12i, So it gives y equals minus 12. Thank you.